Okuma, we understand there's a lot of different machine makes and models and different types of technology, and it can be hard to navigate which model is going to be the right one for your production needs. We've taken some time to put together a return on investment calculator where we can estimate what the cost per part would look like based on different types of technologies and values that you input. Today I'm going to take a few minutes and step through a step-by-step calculator and tell you what some of the inputs mean and what to think through as you go through this spreadsheet. So to start with, we have two different examples. We have a step-by-step calculator where you can go page by page through it, or we have the entire worksheet that will come up at one time. So for today's example, I'm going to go through the step-by-step calculator. So the first thing it's going to ask for is the production parameters. So basically, what type of technologies do you want to compare and what are your production volumes? So for the example today, I'm going to start off by comparing a single turret, what we call a 2-axis lathe, versus a twin turret or a 4-axis lathe, and understand what that would look like in a production environment. So the first cell that you're going to come to after you define what your machine model is going to be, it asks for your volumes. How many parts per year are you doing? So for this example, I'm going to calculate it based on 5,000 parts per year at 340 days of working days per year. The next cell asks for the hours of manned operation. So this is the number of paid hours you are paying an individual to run that production. So in this case, I'm going to use 8 hours just for the example. However, if you're comparing, let's say a vertical machining center versus a horizontal machining center, I may need somebody 8 hours a day at that vertical machining center, but if I go to a horizontal with a 2 APC, I may only need them 4 or 5 hours a day because the machine's going to get some unmanned operations through it. So based on that, I could lower those numbers or add that into unmanned operation hours. The next page we look at are yearly utilization rates, and I break these out by two different categories. One, the yearly utilization rate, that is the overall spindle efficiency of your process. So if you're utilizing things like quick change tooling, for an example, where you can change over parts faster and reduce the amount of downtime on the machine, that's the overall efficiency that I'm looking for in that category. So here for this example, I'm just going to say 35%. And I'm doing that based on the national average right now is roughly 34%. However, your shop and your demands, you may be higher than that. So you put in the values that you believe that you run in currently. And then the yearly machine uptime, this is really more about the reliability of the equipment itself. So if you're comparing a lower quality machine versus a higher quality machine, or perhaps a used machine versus a brand new machine, a lot of times you're going to see a major difference in the amount of available uptime of that spindle. That's going to be taken into consideration on how many available hours you have for your production. So for this example, I'm going to keep them both the same at just 75% uptime. And then the machine cycle time per part, in this example, we're going to say this part is a 9-minute, excuse me, a 9-minute part on both the single turret as well as the dual turret, and I'm doing that for a reason that I'll show you here later on. The scrap rate is the total amount of scrap that you realize per year. And you want to take into consideration the levels of technology and your operator experience as well. So if you're going from a environment where they're comfortable and they're used to running a certain rate, and then you interject a new piece of technology, perhaps we put more fail-safes and more technology into reducing what that scrap rate would look like. That's going to make a difference on what your final end calculations are going to be. Then the final one on this page is the payback period, the length of time in which you want to see that return on investment. What are you basing this calculation on? This might be the length of the contract, or it could just be a amortization that you're looking for the total length to see that return on investment. So for this example, I'm going to put in 5 years. The next page, we look at the capital investment of the machine tools themselves. So in the case of a single turret lathe, I'm going to say $225,000. And for a 4-axis lathe, I'm going to put in a value of, I'll say $310,000. And then the machine depreciation rate, this is basically for your Section 179 tax depreciation. So if you're doing that, just for an average, I'm putting in a 25%, but this is going to be based on whatever your tax rate is. If you're not worrying about a Section 179, don't worry about it. You could leave that at 0 if you needed to. Rigging and foundation setup, this is important because it's really based on the number of machines that you need to fulfill that contract. So if it costs me $10,000 to rig in and set up a machine, but I need 10 of those machines, it's going to multiply that by 10 machines. And same with the fixture costs. So I define this category as fixtures. However, this could be any type of work holding that you need to actually hold the part. So in a lathe, it could be your chucks, your tailstocks, your face drivers, whatever the cost is associated with holding that part. In the next page, we get into more of the expenses that you could incur throughout the production environment. So the routine maintenance, this is just average maintenance cost per year to maintain the equipment. It could be hydraulic oils, Wayloop oils, filters, things of that nature. So in this example, I'm just going to put in a round number of $20,000 for each one. And then the downtime repairs, these are more of your catastrophic failures. This is more when you get into something that is a less reliable piece of equipment. Perhaps it's an older machine where you've lost a spindle drive or unfortunately a collision, things like that. So if you're running technology that has collision avoidance software, maybe it's things like Karen Engineering's detected and different technologies that help eliminate crashes that could reduce your downtime repair costs, that's going to look different between the two levels of technology. For this example, I'm going to put in $25,000 for each one. And again, these are just numbers that I'm putting in just to have some calculations at the end to show you. Missed delivery penalties, that is exactly what it sounds like. If you've entered into a contract that could have a penalty if you miss delivery, this would be an area that if you want to have that as part of your calculation, you could input that. For right now, I'm just going to leave that at 0. And then I'm going to look at the operator per hour dollar rate. So this is a fully burdened rate for your operator. In this example, I'm going to use a burden rate of $65 an hour. That might be high in some areas, might be low in a lot of areas. So look at what you consider your fully burdened rate is for your average operators, and that's where that would be input. Then we get into perishable tooling costs. This is always an interesting conversation because a lot of times this is an overlooked value on how much it costs to actually produce parts. Your perishable tooling costs are real costs that customers encounter, and a lower quality machine tends to eat a lot more perishable tooling than a higher quality machine. So it kind of goes back to the Dr. Edward Deming quote of quality always costs less in the long run. In this example, I'm comparing two brand new Okuma machines. So I'm going to say a 2-axis lathe, I'm just going to put in a value of $25,000. And then on the 4-axis lathe, because I have another turret that I'm going to be tooling up over the course of the year, I'm going to put in $35,000 for that one to show that I'm going to use some more perishable tooling on that twin turret machine. Utility expenses, this would just be based on your previous past history on what it costs to run machine tools. You can input what your best estimate would be on your yearly utilities. And then the cost of floor space, this is how much is that real estate actually worth to you. So again, if you're looking at a contract where perhaps it takes 9 or 10 vertical machining centers to fill that contract, but we could do that same amount of production in 3 horizontal machining centers, well, now all of a sudden I'm going to free up some real estate or not utilize as much, and my cost is going to be significantly lower based on that real estate cost. So whatever you value your real estate at, you would input here. In this example, I'm going to put in $5,000, and that would be taken per machine whenever it does its final calculations. Next area, this is where it's given us feedback back. So in this example, with all things being equal, a single turret lathe is going to cost me $81 to produce that part, $81.46. It's estimating a twin turret lathe, because the machine cost is more expensive, is $90.56. And based on the selling price of $125, that's going to tell you what your profitability is for the year. However, I'm going to go back real quick because, again, I'm comparing everything equal. Well, obviously, a 4-axis lathe is going to produce a part faster than a 2-axis lathe. So on the cycle time, we see on average, we can usually cut, depending on the geometry of the part, anywhere from 30 to 40% of the cycle time out by utilizing a 4-axis lathe. So I'm going to drop the cycle time on my 4-axis lathe from 9 minutes, I'm going to drop it down to 6 minutes, and then recalculate what that cost per part is, leaving everything else the same. And here we can see that our estimated cost per part dropped from the single turret lathe from $81.46 down to $47.78 based on the twin turret technology. That's primarily because, based on the numbers that we put in, to fulfill that contract, I would need 2 of the 2-axis lathes to do the same amount of production that the 4-axis lathe is able to do. So I could do that same amount of production in one machine. So that significantly reduces the cost per part. So as we look at different examples, your spindle uptime and utilization drastically changes these numbers as well. So that's why it's very important to look at where you're at currently, and then what will these new technologies bring to your manufacturing process to help drive your cost per part down. Thanks for taking the time to walk through that with me today. If you're currently looking at new equipment, be sure to reach out to your local Okuma distributor. They can have a more formal conversation about your needs and walk through this in more detail.